And so really what we're going to do is build directly onto the constructions especially that we did in the last section. But before we go through the constructions, I do want to go over some terminology here really quickly. Hey, the whole section itself deals with right angles, perpendiculars, and parallels. So let's talk about some of the terminology that we're going to use here. And the difference between parallel and skew. And when you're dealing with lines or elements that are parallel or skew, they can't be both. And this is like coplanar and non-coplanar, which is part of the definitions too. You can't have something that's both parallel and skew. It's one or the other, or neither. Okay, so if you're using the word parallel to describe a relationship between elements, what you're saying is that they are coplanar lines or parts of coplanar lines that do not intersect. Okay, so if we were to, let's say, take a 3D representation, so a box to represent multiple planes. Okay, if we took this line and this line, those are two lines that are coplanar. They're contained in the same plane, or can be contained in the same plane. However, they're never going to intersect. Those would be considered parallel. The symbol for parallel is two vertical lines. So if I call this line 1 and 2, we would say that line 1 is perpendicular to line 2. Okay. All right, now, as far as individual elements that aren't lines, so segments, let's say, or rays that are parallel to each other, the only way those can be parallel is if they're contained on parallel lines. So if you had two segments, let's say here's two segments that are coplanar and that do not intersect, right, because they stop before they intersect, these would not be considered parallel. And the reason for that is if you extended these lines, are these elements contained on lines that are parallel to each other? No, they're contained on intersecting lines. So the elements themselves, the segments themselves would not be parallel. It's not until you get to, let's say, two segments or rays or some other element. If you had these two segments that are on, or they're portions of lines that are parallel to each other, if that's the case, then the segments themselves would also be parallel. Now remember, the marking for parallel is an arrowhead pointing in the same direction. That indicates that elements are parallel to each other. Now, in contrast to that, skew means that these lines are not on the same plane and they do not intersect. And that would be in reference to skew. Now, it's kind of a redundant concept. That's why I put it in parentheses here. But if you have two lines that are non-coplanar, there's no way that those can intersect. So if I have this line here and this line here in that three-dimensional box representation, those lines are never going to intersect one another. And those would be an example of skew lines. And now, the fact that they don't intersect and that they are not parallel is all kind of embedded within this simple definition that skew lines are simply non-coplanar lines. If you have two lines that cannot be contained in the same plane, they will be skew lines. Otherwise, they would either be parallel or intersecting lines.